The last thing we need to talk about is a term called specific heat. It is defined as the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Every substance in this world has a different specific heat. To give you a couple of examples, let's take a look at water's specific heat, which is 4.18 joules. Remember that the joules represent the energy per grams degrees Celsius, which would be the mass and the temperature change. Whereas iron and gold have specific heats that are a lot lower. Iron specific heat is 0.449 joules per gram Celsius, and gold has a specific heat of 0.129 joules per grams degrees Celsius. Think of those values as dollars. Basically, it would take $4.18 to get 1 gram of water to raise by 1 degree Celsius, whereas it only takes 45 cents to get 1 gram of iron to raise by 1 degree Celsius, or only 13 cents to get 1 gram of gold to raise by 1 degree Celsius. The higher the specific heat, the more energy it takes to change its temperature. In the next section, we will look at how to calculate specific heat or use it to calculate the amount of energy that is released or absorbed by a substance, its mass, or its temperature change. So stay tuned. So let's tackle some heat calculations. The first thing that you need to be able to recognize is that the symbol C in the equation is going to represent specific heat. And on your reference sheet, you will find various values of specific heat for metals and for water in solid, liquid, and gaseous state. Q is going to stand for heat energy, and it will be either in joules or calories. M will stand for mass. Remember that the most common unit here will be grams. They might give it to you in a different unit, but according to the specific heat value, which is in joules per grams Celsius, you will need to make sure that this is in grams. You will need to make sure that your heat is in joules and that your temperature is in the Celsius scale. The delta T stands for change in temperature, and you will be subtracting the initial temperature from the final temperature. So if you take a look at the equation at the bottom, you will see that it says C, specific heat, is equal to the amount of heat per gram of substance and with a temperature change. Another way that you can write that is by cross multiplying. We would end up getting Q is equal to M times C times delta T. This is actually the form of the equation that is found on the reference sheet. You do not have to memorize this equation. It is given to you, and you can use either form, but this is the form that's on the reference sheet, so that's usually the one that I would look at. So example 1 says that you have a 155 gram sample of an unknown substance, and it's heated from 25 to 40 degrees Celsius. The substance absorbs 5,696 joules of energy. What is the specific heat? So we're going to go ahead and we're going to use the equation. Q is equal to M times C times delta T. We know that the mass is 155 grams. We know that the delta T is the final minus initial temperature. So this is your T final and this is your T initial. So we're going to take 40 minus 25, and that will give us 15 degrees Celsius. And then they give us joules of energy, and so that would represent your Q. Now that you have determined the known amounts, you can see they're asking you for specific heat, which is C. The equation is right here, and we're ready to plug and chug. So we're going to take 5,696 joules, and that's equal to 155 grams times C, which we don't know, and the change in temperature, which is 15.0 degrees Celsius. Alright, so in algebra we want to get the unknown variable that we're solving for by itself, so we're going to divide both sides by 155 and 15. And that will get those canceled, leaving me with C is equal to, and when I divide 5,696 by 155 times 15 degrees Celsius, that will give me an answer of 2.44989. Remember that the least number of sig figs in the problem was 3. We've got 3 here, 3, 3, and 4. So we're going to take it to 3 sig figs, which puts me at 2.44. That's going to cause that to jump up. So really my answer is 2.45. And notice that the joules, grams, and Celsius did not cancel out. And those happen to be your units of specific heat. Most likely, you would then have to identify the unknown substance, and you can do that by matching up the specific heat value to the substance on the reference sheet. So let's try another example. Go ahead and turn the vodcast off, try this one on your own, and come back and see the answer. As I read the problem, I notice that they're asking me to solve for how much heat. Remember that heat energy is measured with the variable symbol Q, and it's needed to change the temperature of 12 grams, that is going to be my mass, of silver with a specific heat of 0.057 calories per grams degrees Celsius. So we're going to label that with a C, the symbol for specific heat. And they're telling us the temperature is changing, and the initial temperature is 25, and the final temperature is 83. Using the equation, Q is equal to mc delta T, we're going to solve for Q. We know the mass is 12 grams. We know the specific heat is 0.057 calories per grams Celsius. And the change in temperature is going to be 83 minus 25, or 58 degrees Celsius. So right off the bat we can see that our mass units will cancel out, our Celsius units will cancel out, and now we're going to do the math. So Q will equal 12 times 0.057 times 58. And your answer is 39.672 calories. We have 3 sig figs here, we only have 2 sig figs here, and both of our temperature values have 3 sig figs. 2 is the smallest number, so that would be 39. The 6 is going to cause that to change up, so it's really 40 decimal point, or 4.0 times 10 to the first calories. Now, if the question had asked you how much heat in joules, we would have to use our conversion factor that we mentioned a couple of slides back. But in this case, it does not matter because they were very general with what unit they wanted heat to be in. So remember, calories and joules are both possible units for heat energy, or possible units within the specific heat value.